I had a derivation for this, but I wasn't happy. And I've done a derivation for the center mass of a right triangle. And you could use that here. You could cheat, but I wanted to just do it from scratch. Let's just 100% do the center mass of a triangle. Not a right triangle, not an isosceles triangle, not an equilibrium triangle, just a normal triangle. Done. We're going to do it. I'm going to do it 2 ways. So remember that we define the center of mass as the sum of each mass element, if I had elements, times its vector position divided by the total. So we're just going to do the x and y direction. So and as a sum, but we're going to do it as an integral. So if you want, we could do x center of mass as the surface area integral of m dm x over the total mass. Is that okay? That's okay. And then the y center of mass as that's an area integral of dm my over the total mass. So let's do that, and we want to do this as simple as possible with a generic triangle. So I'm going to pick my coordinate system to make it easy for me. I think this is easiest. So and you could arrange this triangle in any way that you want, but I'm going to arrange it like this. So I missed. So that's my x-axis, and that's my y-axis. So I have a point right here, one of the vertex at the origin, and then I have one of the lines, one of the sides is parallel to that. So this is in the x direction. And again, it just makes it a little bit easier for me. Now let's pick some values here. So I'm going to say this is h, this is a, and this is b. I guess I should call that c. Let's call this c, like that. So the distance from here to there is c, and then the distance here to there is a, and there to there is b. So that is useful because now I can write an equation for each one of these lines, which is what I'm going to need. Okay, so this one, since it has a 0 intercept, all I need to say for right there, I'll call this y1. y1 is going to be equal to the slope, and the slope is positive, right? So the rise of c over a x. That's not too bad. And this one has a negative slope, y2, a rise or fall of c over b, negative x. So now I have the equation to those two lines. I'm going to need that. Let's start with a picture, and let's find the y center of mass. So one of the things that I said before, I said this in a blog post, I said that the center of mass was 1/3 of the way up. And I was pretty sure it was true for any triangle, but let's just show that that is infactually true. And infactually is a new word that I dislike. So here's my triangle. Let's draw it again. I'm going to try to be better. And that doesn't look perfectly correct, but that's fine. Oh, look, I hit the vertex that time. Okay. So what I'm going to do is, this is my x in my y direction. I want to find the y center mass. So I'm going to break this into rectangular pieces. And the width, the height of that is going to be dy. So now I can find the area of this piece. And I need that because I can say the mass, dm, is going to be the area of that piece, dA, divided by the total area, right? The ratio, the mass of this whole piece is the same as the ratio of the mass of the areas of the whole piece. This piece to the whole area. So now I guess I got to find the area. So that's not too hard. So the area is going to be 1/2 base times height. So it's 1/2. The base is going to be a plus b, and the height is c. So that's my area. Now what about this differential area right here? Well, I can write that dA is going to be the height of dy, and then the length of this is going to be this value, y2 minus y1, right? Because it goes from this side, y1, to that side, y2. And remember, y1 is, what was it? C over ax, y2 is negative b over ax. So if I put that in, I get dA is going to be dy, y2 is negative b over ax, minus this, minus c over ax. But you know what? I think I'm going to change that. I'm gonna not write that because I'm gonna write an integral over y, and I don't want to have x in there. So I can I can find the x values over here. Those are the, no, wrong. Okay, that's what dA is going to be. And I wonder how many people are like watching that. He is so wrong, and then just stopped, and they're no longer in this video, and they can't see that I made a mistake. It's okay to make mistakes. So it's dy times the length in the x. So it's going to be x2 minus x1. And so now over here, I need to get x1 and x2 in terms of y, right? I could call this x1, x2. Because I'm going to integrate over y. So if I take this, I get x1 is going to be equal to a over c y1. x2 is negative a over b. That's a c. Wow. Wait. It's rise. It's negative c. I should just start over, shouldn't I? But I'm not gonna. Nope. That just shows you the people that are really committed to this, that would follow through with my errors. Okay, so that one's right. It's the rise of c over a. That's right. And this is negative c over b. Okay, so then x2 is going to be negative b over c y2. And I can just take that in general y. So now this is going to be equal to dy times x2 negative b over c y minus a over c y. Yes, I'm happy with that. Okay. Now we're going to integrate. So we want to find the y-center mass. I can write the y-center mass, in this case, is going to be the integral from y equals I'm going to integrate from here to there. So negative c to 0 of y dm, which is going to be dm is this, and that's that. So I get 1 over a, I'll just write it as that, the integral from negative c to 0 y times dy, dA, which is this whole thing. So I'm going to put it as, I can factor out the c. Should I do that? Yes. Let's factor out the c, and I'll put it over here. AC, yeah. And then I can factor out the negative too. So now I get by plus, that's a y, plus ay dy. Now, I can do that integral. Don't you think I can do that integral? I think I can. So that's going to be equal to negative 1 over ac times the integral. Now I have by squared. If I'm going to integrate that, I get b over 3y cubed plus a over 3y cubed from negative c to 0. Now let's evaluate that at the limits. And so you see here that I have nice limits because one of them are 0, and I'm going to get that much easier. So I get negative 1 over ac times 0 put in there, I get 0, minus this with negative c. So negative c put in there, I'm going to get negative c cubed. But then I have a negative right there, so it's going to be plus b c cubed over 3. And same thing over here, plus a c cubed over 3. Now let's go ahead and put in, my thing froze up, okay. Now let's go ahead and put in our value for a. So I'm going to switch to a new piece of paper. So y-center mass is going to be negative 1 over a, and I have my a value as 1/2, I'll put the 1, I'll just write it 1/2 a plus b times c, and then I have all that stuff. I have b c cubed over 3 plus a c cubed over 3. I'm going to factor out a c. I can do that. So I get negative 2 over a plus b, And then I can factor out a third and a c. So I get 1/3 c squared. And then I get b plus a. And now we got the magic here. Look, it's happening. So I get negative 2/3. Those cancel. I think I should get like another c. Where'd the other c? I had c squared. Oh, I have c squared down here. Why is there a c? Oh, you know what? I had that c. Okay, so this is c squared, right? Because see, over here, I had c times a, and a is 1/2 abc. So, yes, I made another mistake. It's fine. But I saw it. I caught it, right? Because I caught it because I know that the y-center mass has to have a distance unit. It can't have c squared. And so this is what I want. And that's what I was looking for, right? Because this says the distance from here to there is negative 2/3 the height. So the distance from the bottom is 1/3 of the height. And I was right. And it doesn't matter about the dimensions. So I was right. Now let's do the x center of mass. So x center mass is going to be equal to the integral of x dm. So for this, we're going to break our triangle into vertical slices. Like this. And we're doing this because if I don't have to worry about where in the y direction that I can treat it as a single point. And it doesn't really matter about its y value. I'm adding up in the x direction anyway. And so this has a width of dx, and it's going to have a height of y. It's going to have a length of y. Okay. But I want to get dm, so I can say dm is going to be dx times y minus c, right? Because the bottom down here is c. So the height right here minus that height is going to give me my total height. But I want to get y in terms of x. And I'm going to integrate from here to here. I'm going to use my y1. And then when I integrate from here to there, I'm going to use y2. So I'm actually going to break it into two integrals. So let's just write it all down. We can do that. I want to get to the next part because that's really I'm excited about. So my dm, actually this is over a. They're still over that a. So I have 1 over a times the integral from x equals negative a to 0 of x times y1 minus c. And remember, y1 is this, c over a. So it's c over a x minus c dx plus 1 over a 0 to b, right, because I'm doing the second part, of x times this value of y, negative c over b. So it's going to be negative c over b x minus c dx. Let's do this on another piece of paper because you know I'm going to run out of room. Okay, so I'm going to do this in one fell swoop, 1 over a, which is a bad idea, but I'm going to do it anyway. So here I have x squared, so the integral of x squared is going to be x cubed over 3. So I get c over a x cubed over 3, and then I have cx, so that's just going to be cx squared over 2. And that's going to be from negative a to 0. And then over here I have plus 1 over a, and I get negative c over b x cubed over 3 minus cx squared over 2 from 0 to b. Okay. Wait, what's the c over a? C over A. It is C over A. A, I said A, not A. I wasn't even listening to myself. But I caught my error, so that's good. So here I'm going to factor out all these C's and the A's. Yeah. So I get C over A. And then here I have 0, 0. So those are both 0. And then I'm going to put in negative A. So I get negative A, minus a negative A. So it's plus A cubed over 3A. And then I put in A for that. I get minus, I'm on the minus side, right? So it's minus this. So it's positive, and that's going to be positive. So I get plus C A squared over 2. And now this one I have, I put in B, so I get minus C, no, I factor out the C, B cubed over 3B, right? B cubed, B, 3. And then I have this one, which is minus C B squared over 2, and then I put in the zeros, and that's fine. Okay, so I get some stuff here. So I get C over A, and then this is A squared over 3, and that's A squared over 2. So I get A squared over 1/3 plus 1/2, which is, I can't do that in my head. So it's going to be 6, 2/3, 2. It's going to be 2/6 plus, it's going to be 5/6. Isn't that right? See, so 2 over 6, 3 over 6. Yeah. And then here I get minus, I'm going to get the same thing. B squared 5/6. Okay, so let's put in our value for A. So here I get a 2 on the top, right? Because it's 2C over A plus B times C, which cancels. And then I have A squared minus B squared. And that cancels. And you'll notice that I do get, actually I think I could probably write this as A plus B times A minus B. Yeah. Well, there's a 5/6. Still at 5/6. So then I think this is actually wrong. So I'm going to write this as A plus B times A minus B, and then the A plus B cancels. So I get 5/3 times A minus B. I don't think that's right. But at least it has the right units. And it doesn't depend on C. So that's kind of cool. Okay, let's do this another way. I want to do it in Python with a numerical calculation. And my favorite way to do this. Okay, so let's imagine that I have my triangle here. You know, we calculate the external mass as the sum over I, mi, xi, over the sum over I, mi. And so if you have an infinite number of points, it becomes an integral. But if you have a finite number of points, suppose I have points all over here spread evenly or not evenly, but kind of evenly, then I can just take the x value of all these points and add and multiply it by its x value, add those up, and divide by the total mass. That's what I'm going to do. I'm going to do this as a Monte Carlo calculation in Python for no other reason other than I think it's fun. Okay, so if you just wanted to get the calculation, and I think my x center mass was wrong, I'm almost positive about my y center mass, but we can check it. So let's switch over here to Python and get started. It's going to be great. Okay, I'm using WebVPython just because we do have these three-dimensional things. Now, if I'm doing a random calculation, the first thing I need, a couple things I need. Number one, I need how many points am I going to have? So let's say n equals 100. Let's just start with 100. We can change it later. And then I always like to do n equals 0. That's my counter. So I'm going to count up to 100. And then I'll just say while n is less than n, n equals n plus 1. That's how I do it, right? That's how I count to 100. Okay. Now I need also values for A, B, and C. So I'm just going to pick some stuff. So A equals 1.2, just so it's not the same. B equals 0.3, and C equals 1, because I really want that height. And so if I put my triangle height at 1, then when I calculate the center mass, it should be negative 2/3, which is easy. I don't have to worry about any conversions, stuff like that. I want to draw my triangle. I'm going to draw it by drawing some lines. So that means I want those 3 vertex points. You don't have to do this, but it's going to help me make the things right. So I'm gonna call this P1 as the top. So it's at the origin. 0, 0, 0. P2 is the point on the right down there. So it's going to be vector B negative C 0. And then P3 is the other point on the other side. And it's going to be equal to the vector negative A negative C 0. Now I'm going to draw lines between them as a cylinder, which you don't have to do. So I'm going to say I have a cylinder. It's going to be at the origin, so it's going to be, its position is P1. And then the axis is going to be from P1 to P2. So it's going to be P2 minus P1. And then the radius is going to be, let's use, this is down here. Radius is 0.01. Let's just do all 3. And if it doesn't work, it doesn't work. So I'm going to copy that and paste it twice. And the other one's going to start at P2, and it's going to go from P2 to P3. And the other one's going to start at P3, and it's going to go from P3 to P1. Let's run it. There's my triangle. It's in 3D too, but it doesn't really matter. Awesome. It took a little bit longer than I thought it would, and I was kind of surprised. Scared me a little bit. Okay, so now we can start making our numbers. Now, I do need one thing. I need the mass, right? So let's say m equals 1. It doesn't really matter. And then dm, the mass of each piece, which again doesn't really matter because it's going to factor out, is going to be m divided by n. Now you've got to think, how do I distribute points in a triangle? That's really the question. And you may be tempted to use some tricks, but let's just say I'm going to make a square of points. And if I make a square of points, I know that they're evenly distributed and it's going to be fair. If I try to make like a rectangle or something like that, it's not going to work. So I always want to start with a square or cube of points and then cut away what you don't want. That's the key. Okay, so is this big enough? So let's go with my largest dimension is A. So I'm going to go with a square of size A by A, and no in the Z direction. So let's go down here and make a random vector. So I'm going to call it RT. It's going to be a vector, and it's going to go from negative A to A. So I can do that like this. A times 2 times random minus 1, 2 times random minus 1, 0. So random gives you a number between negative 0 and 1. So if I multiply that by 2, it's 0 to 2. If I subtract 1, now it's from negative 1 to 1. I multiplied by A, and there we go. I'm going to put a sphere at this location. Sphere position equals RT, and a radius of, let's say, 0.01. And let's just see what happens. I should have 100 points, and they will not be in the thing. There. So they go from negative A to A and negative A to A. So it's way more points than I want. So now we need to kind of like cut them down. The first thing I'm going to do is to say, I don't want any positive Y values. So if I go up here, I could change this to 1,000. That looks a little bit better. I don't want any of these points that are positive. So if I say if RT dot y is less than 0, then make a sphere and then add a point. But I'm still creating the points in the whole square. I'm only counting them if they're less than 0. Now when I run it, it looks a little bit better. See, now I've cut off that top. Now I'm going to cut off the bottom, right? Because I don't want them lower than C. Now, you have to be careful. I have to use my largest dimension so that the triangle fits inside of there. So let's cut off the bottom. So I can just say, and rt dot y, which is the y component of that, is greater than negative C. Or, yeah, because I put C as a positive value. Now I'm going to run it. See, we're cutting things out. Now I want to see if my x value is greater than this, right? So I need to calculate, once I calculate my point, I need to know what the x value of that line is. So let's go up here and do a trick. So I generate my random variable right there. Let's calculate the x value of the left. I'll say xl. That's the left value for that particular point. It's going to be a times rt dot y divided by c. That's my equation that I had before, right, for x. So that's my left value. I'm going to go ahead and calculate the right value too. X right is going to be negative b times rt dot y divided by c. So I want to see if it's greater than xl. So I'm going to say and rt dot x is greater than xl. You see how we're like whittling down our points. Now I'll have to say and x is less than r right. So one more. And rt dot x is less than x right. And I have 1,000 points in a triangle. Isn't that cool? You can zoom in if you want. You can zoom out. You can rotate. There's no need to rotate, but you can. You can rotate it. And you could count. If you want to pause this video and count those points, there's 1,000. Because over here, I only increment the value of n if that following condition is true. So now we don't even need to draw the points. I think it's really useful to display those points graphically, so you can make sure you cut everything out right. But you don't. I could just get rid of this sphere and it wouldn't draw them. But I'm going to leave it there because I like it. So now we want to calculate the y center mass and the x center mass. So I'm going to add up x, the x value of all those points, times their mass, and add it to something, which I need to start with something. And then when I'm done, I can divide by the total mass. So let's make two new variables. Y center mass temporary is 0. X center mass temporary is 0. And it's temporary because I didn't divide yet by the total. You could get around that pretty easily. So down here, what I'm going to do is just, I know my variable is in the triangle. So I can say x center mass temporary is the old x center mass plus rt dot x, that's the x value, times dm. That's it. And then I'm going to do the same thing for the y. Y center mass equals y center mass plus rt dot y times dm. And then down here, I can print those out. Print xcom equals xcom t divided by m. I was trying to see if it has, no, I don't really need the units. And then print ycom, and the com stands for center of mass, just in case you didn't know that. Ycom t divided by m. Let's do it. So the x center mass is negative, right? Because there's more of that triangle sticking in the negative side than on the positive side. And then the y center mass is negative 2/3. That is negative 2/3, right? Negative 2/3 is negative 6.6. And I could increase this value. I don't have to do, if I can do 1,000, I can do 10,000. And there you go. It works. Let's just, one more thing. Let's put a dot there. So I'm going to make these spheres super tiny. So put 0, 2. And now I'm going to put a center mass dot. So let's just say sphere position equals y, a vector y comt divided by m. Oops, divided by m. What the heck am I doing? Divided by m. Y center mass t divided by m. That's my x and y values, and then 0 z value. And then let's give it a radius of, let's say, a over radius equals a divided by 10. And let's make it yellow. Maybe we can see it. If we can't see it, I'll just make it bigger. So let's go back up here, run it. And that's big. We don't need it that big. Let's make it a, I want a divided by 50. There. Center mass, done. Art. I didn't check the external mass because I'm afraid I'm wrong, but I'm pretty sure that's right. There you go. It's a great example of Monte Carlo calculations. That's what I love about it. You know, it's a challenge to kind of like think about how to cut that thing. You're basically a math butcher. You're a random number butcher. What am I cutting away until I'm left with what I want? And that's what I like. The end.